going to do the first half of lesson 2 today and the second half tomorrow, but I might have you watch the video for the second half for your homework tonight so that we can do like more rotational type centers tomorrow. So we talked about an expression and we talked about an equation yesterday. Can you turn to a neighbor and discuss the similarities and differences? Go. As it says in our definition on page 139, an equation is made up of two equal quantities or expressions. So an expression is a number or numbers that holds value. Okay? An equal sign is used to show that the two sides of the equation are equal, kind of what we talked about yesterday. It's got to be balanced, both sides. If it's not equal, it's not balanced, right? So we show that with this is an equal sign, just for, basics of it all. And this is a not equal sign. You can write that in your notes. You need to write on page 139, for number 1, it says use the equal sign to write 4 equations. Vary how many numbers you have on each side of your equations. And something interesting was brought up, but I'm doing this for the video. You have to use expressions, because an expression can be one number. Now, should we have any variables in this? No. Just write straight up expressions that equal. Go. Write 4 equations. But what I want is, it can be as basic as 6 equals 3 plus 3. That's basic. That's a basic equation. 6 is an expression that equals 3 plus 3, which is an expression. You could do 50 times, hold on, 10 times 5 equals 100 divided by 2. That's a little more complex. As long as both sides are equal. Or if you have 3 times 2 plus 4 equals 20 divided by 2. Is that equal? You see what I'm doing? Okay. Now I want you to try to, and this might be a little harder, I want you to try to use the not equal sign to write 4 statements, 4 equations. Well, it can't be an equation, right? Because it's not going to equal. So I want you to write 4 statements and vary how many numbers you have on each side that are not equal. The balance is not there. So we are not writing equations. So like this. What did you have, Carson? Right? Right? That is a statement. It is a non-equal number statement. This one hopefully will be a little easier. Go. So the non-equal ones either were a lot harder because you were still thinking everything equals, or you made them really easy. So 3 times 2 is not equal to 6 times 3. So now using those skills and using your order of operations, what I need you to do on numbers 3 through 8 is you need to either write an equal sign or a not equal sign to make these statements true. So if I'm doing the first one, 5 plus 2 is 7, and 7 plus 6 is 13, right? 6 plus 7 is, so this one would definitely equal. 18 take away 4 is 14, plus 11 is 25. That definitely does not equal 3. So I need you to take your number detective skills and do those 4, writing equal or non-equal. Go. Number 4 would be what? Not equal. Very good. You can look at that in a glance and know that that's not equal. Number 5, equal or not equal? Equal. Well done. Number 7, you have to do what's in the parentheses first, right? In the parentheses first. That does not look equal to me. What about number 8? You've got 27, take away 3 is 24. You've got 22 plus 2 is 24. So that must be equal. The inverse operation is the opposite operation. So what's the opposite of addition? Subtraction. What is the opposite of multiplication? Division. Okay, and vice versa. So when you add, you put 2 groups together. When you subtract, you find an unknown add-in to take away one group from the other. Addition and subtraction are inverse operations. They undo each other. So if I were going to add a person to this group, now I have 7. If I were to undo it, I'd have to subtract it. Okay? So add-ins are numbers that are added to make a sum. Thumbs up if you know that word, add-in. You've heard that before, right? Add-in is the 2 numbers that you add. You can find 2 add-ins for a sum by breaking apart the number. So it's kind of like what we were doing with multiplication when we were taking the 45 and putting it with 40 and 5. Those were 2 add-ins, right? Do you remember that? That was a long time ago. So a break-apart drawing can help you find all 8 related addition and subtraction equations for 2 add-ins. So if you have 81, it's just like fact families, right? 81 is 72 plus 9. It could also be 9 plus 72. It can also be 72 equals 81, take away 9, 72. I want you to circle the 81s. 81, 81, 81, 81, 81, 81, 81, 81. Do you see how the opposite operations and what they're doing to the number and how you're getting the number? Just look at those really fast. Just read them. Commutative property. It's that 3 plus 2 is 5, and so is 2 plus 3 is 5. You can flip the numbers either way. And 5 take away 3 is 2, and 5 take away 2 is 3. That's that commutative property. So which equations show the commutative property up here? Which ones? So the commutative property I have shown up here in green. Commutative means 72 plus 9 and 9 plus 72. And it's flip-flopped either way. You can do it either way. So the reason, let me tell you the end game. Maybe if I tell you the end game, why we're picking this apart right now. You have to know these words because the end game is we're going to be solving a lot of word problems where you have to set up the equations, okay? And if you don't know how to set up an equation, if you don't understand what you're adding, what you're taking away, you're not going to be able to set up an equation to solve the word problems. That's where we're going with this, is how to be problem solvers and solve word problems. Okay? So, no, that's why we're doing all of this business. Okay? So, with solving these equations, 11, 12, and 13, we talked about it yesterday. In order to, and I'm going to make number 11 bigger over here. In order to figure out what P is, what do I need to do? I need to figure out what was added to 30 to get 50. How do I do that? Use, everybody say it. Use the inverse operation, which is subtraction. But what I like to do, and I'm just going to put this in here right now, is I subtract 30 from each side of the equation. Because if I subtract 30 from over here, what do I have left? 0. But I have a P left over, right? So if I subtract 30 over here, what do I get? Ta-da! Can you try that with 12 and 13 by yourself? Yep. Quietly. Your next challenge is to write 8 related addition and subtraction equations for this break apart drawing. So 56 equals, I'll write the first one. So basically you're doing this right here for 56 instead of 81. So you can look at this as your model, and I will do the first one for you. So 56 equals 48 plus 8. So now you have to write 7 related equations like we did for 81 up here. Hit it. So when we get to tomorrow, we're going to talk about, or tonight possibly in another video, we're going to talk about situational expressions and solution equations. So you have like your basic expression and equation that you need to figure out, but there's holes in it. And then you figure out another equation to figure out the hole. Okay?